Here, we're going to talk about multiplication, just fundamental basic multiplication, but let's start off and get those pesky negatives out of the way. First of all, remind yourself, what does negative mean? Negative sign really only means other direction. That's it, other direction. So let's make sure and do one. If we do 5 times 6, we get a 30. If we put a negative on one of those numbers, so we get negative 5 times 6, we still have 30. We just have it in the other direction. That's it. If you have a negative 5 times a negative 6, then it's 30. We have one other direction. We have the other direction. And what happens when you go the other direction? All gone. That's where we get two negatives make a positive. So that's great. That's really all that deals with negatives. So now let's try the next little thing. Let's look into what makes multiplication work. If we were to take 400 times 20, 400 plus 400 plus 400, how many times? 20 times 400. If you add all that up, you actually do get 8,800 or 8,000. 8,000, that's exactly what actually comes out of this. And there are a couple of things we need to note about this. Number one, the 4 and the 2 did not line up with decimals at all. So that's one thing we need to know, that normally with addition we would have like things. Normally we would have like things with adding. Well, here we don't have to. In decimals, that means that we don't have to line up decimals. None of that. And with fractions, we used to have common denominators. And since we don't need to have like things, with multiplication, we won't need common denominators in fractions. Multiplication is nice that way. Anything, any place value can multiply any other place value. In slow motion, let's look and see. We had 4 hundreds times 2 tens, and we ended up with 8 thousands. That's going to be important. We started with tens and hundreds, and we times them together, and we ended up with thousands. That's kind of important. Okay, so let's look and see how this actually works out. We take a problem like 3,846. We're going to times it by 57. Now, to do this so we can all see where it comes from, we're going to do it in a couple of different colors here. Times 57. So here's the distributive property. We're going to take this 7, we're going to distribute that 7 through every single one of them. 7 times 6 is 42. That's a 2 down here, and then 4 tens. So 7 times 4 is 28, plus 4 is 32. Put a 2 down there and a 3 up there. 7 times 8, that's 56. Plus 3 is 59. And put the 5 up there. 7 times 3 is 21, plus 5 is 26. Oh good, there we have it. Now if we go and do this next one, 5 times 6, oh wait, don't do that. We got to put a 0 down here first. If you've ever wondered why that happens, this 5 isn't a 5. This number is 57, so that 5 is actually a 50. So putting this 0 down here ensures that we're actually taking 50 times everything when we run this 5 through. So now let's do it. 5 times 6 is 30. There's 0, carry the 3. 5 times 4 is 20, plus 3 is 23. 5 times 8 is 40, plus 2 is 42. And 5 times 3 is 15, plus 4 is 19. Shazam! Now, notice what we're doing. We're now adding. That should be a little bit weird. Why are we doing that? Because this is 7 times 3846, and this other guy was 50 times 3846, and we're adding those so we get, as a result, 57. So that's where this addition comes in. So we add and we get 2, 2, 9 plus 3 is 12. Carry that little 1 there. 1 plus 6 plus 2 is 9. 2 plus 9 is 11. And there we have it. 219, 222. There we go. Now, this is what happens when we're just multiplying normally. We can come up here and say, oh, what if we had a negative here? Well, we'd get a negative down there. What if we had a negative on both of them? Two negatives would make a positive. Now let's go and look and see what happens with decimals. If we take this statement right up here with hundreds and tens and write it out just a little bit different, let's do it with 0.04 times 0.2. Now this is 4 hundredths times 2, with a th on it, tenths with a th on it. We better get, if this really happened, 4 hundredths times 2 tenths is 8 thousandths. 4 hundredths times 2 tenths better be 8 thousandths. Better happen exactly the same, and indeed it does. And this is where we get the shortcut. 2 times 4 is 8. Now, notice we better have thousandths. So this is it. And here's the shortcut. Here, there are 2 places behind the decimal. And here's 1 place behind the decimal. That means we need a total of 3 places behind the decimal. It really comes because that's a hundredth, that's a tenth, that's a thousandth. So if we were to go back into this problem right here that we did, 3846 times 57, and put decimals somewhere. So like that guy right there and that guy right there. This 6 is in the hundredths place. This 7 is in the tenths place. So hundredth times tenth is thousandth. 1, 2, 3. 1, 2, 3. Our decimal would go right there. And yep, that guy ends up in the thousandths place. It's pretty nice. Let's do one more of those and see if we can see it in action. 483.7 times 9.2, and I'll do it in the different colors so we can see it again. 9.2. Let's do it. 2 times 7 is 14. We're ignoring the decimals right now and just getting the numbers. We'll do the decimals at the end. 2 times 3 is 6, plus 1 is 7. 2 times 8 is 16. And 2 times 4 is 8, plus 1 is 9. Now let's run this 9 through. Now remember, if we're ignoring the decimals, that 9 is not a 9, but is a 90. So let's do that. 9 times 7 is 63. 9 times 3 is 27, plus 6 is 33. 9 times 8 is 72, plus 3 is 75. And 9 times 4 is 36, plus 7 is 43. Good deal. Now, again, we're going to add. Here's our 2 times 4837, and here's our 90 times 4837. And so we add them together, and we get 4, 7 plus 3 is 10, carry the 1 is 10, carry the 1 is 15, carry the 1, that's a 4, and that's a 4. Now we pay attention to the decimal. We have 1 place behind the decimal, 1 place behind the decimal, so our answer should have 2 places behind the decimal to add those up. There you go. And our answer is 4450.04. Good deal. To finish up over here, let's make sure we do the fractions. Let's rewrite this thing. 4 hundredths times 2 tenths. And our answer was 8 thousandths. Again, look at this. No common denominator necessary. That's great. And with multiplication, it appears that where the numbers are placed, we just multiply straight across. That's wonderful. So if we had something like 3/5 times 4/11, you will do 3 times 4 is 12. 5 times 11 is 55. And that is all there is to multiplication with fractions. It turns out to be easier than addition because you can just multiply straight across.